Good morning, and welcome to Dalhousie's Faculty of Computer Science Preview Day. I wish I was with you in the Faculty of Computer Science building in the auditorium, and we were about to go on to a collection of interactive demos, but that's not possible today. So I thought I'd take a few minutes to record this and give you a feel for what computer science is, for what studying in the Faculty of Computer Science is like, and about the kinds of opportunities that it affords you. So my name is Andrew Rau-Chaplin, and I'm the Dean of the Faculty of Computer Science here at Dalhousie. So here's our building, right along University Avenue there. And I'm going to spend just a couple of minutes this is it in 2 minutes. Here's the main message. Why study computer science at this time? Well, technology is quite literally reshaping the world. It affords opportunities both for individual creative effort and collaborative work. It's spread in terms of its application across society. The opportunities in computing at this point are endless. In terms of rewards, it offers an opportunity to do a variety of types of work in an industry with employment, and that offers great careers here in Halifax, Nova Scotia, in Canada, and internationally. And lastly, it's a very flexible degree. It allows you to combine computer science with many other disciplines. It allows you to take many different paths from a degree in computer science into other areas which you're passionate about. We live in such interesting times. I mean, software is literally transforming the world. Think about it. Entertainment. How do you watch movies? How do you listen to music? Think about advertising, gaming, society, fundamentally how government works, the underpinnings of a modern healthcare system, the underpinnings of a modern society's advancement of science, all rely on software and computing at their heart. Industries are literally being transformed. Everything from pharmaceuticals, oil and gas, even industries, traditional industries like the fishing industry, make extensive use of data analytics and computing to change the way they operate, to change their footprint on the landscape or in the ocean, fundamentally different than they were just a few years ago. Think of the way we use services, particularly at this time. Banking, taxis, travel, shipping, design, all of them underneath are a question of software. So a degree in computer science prepares students for a diverse range of careers. You can be a builder, craft, some software engineer, a network engineer, a security specialist, a software architect, someone who applies AI and machine learning to problems in many different domains. Or you can be a designer. Think about user interface design. Think about game design. How important studying that human in the loop of the technology and designing systems that are easy to use and fluid. Also, strategists, product managers, technical sales, scientists, data scientists, cryptographers, specialists in AI, managers of all sorts, shapes, and sizes, project managers, software analysts, and lastly, of course, executives. Fundamentally, as technology and computing changes what an organization can achieve, its reach and level of ambition, more and more of the executives in organizations come from computing backgrounds, whether they're chief information officers or chief technical officers or the like. So let me tell you a little bit about the Faculty of Computer Science at Dalhousie. It's the leading computer science program in the Maritimes. We have two fundamental undergraduate programs, over 120 different courses in a wide variety of computing topics that you can take. Dalhousie is one of the 15 top research institutions and universities here in Canada. That gives you all sorts of opportunities to bridge from your core discipline, let's say it's computer science, to all sorts of other areas of science and society. And of course, we have very, very strong links to industry. We pride ourselves in doing not just the theoretical, but also the applied. World-class research groups within the faculty, really in four main areas: machine learning and AI, network systems, cybersecurity, human-computer interaction and graphics, really studying the human in the loop of the technology, and digital health and bioinformatics. So I mentioned that we have two undergraduate degrees. Let me tell you a little bit about them, their similarities and their differences. So we have a Bachelor of Computer Science degree. This is a classical computer science degree. It's really about becoming a creator of new software technologies. You do courses in areas like development or programming, mathematics, and it really creates depth within computer science. Key values in this degree are values of design and coding, of craft, of building, being a builder of new things. Key skills: problem solving, design, analysis, coding, and technical excellence. In terms of sort of high school requirements, we're looking for obviously a grade 12 English, pre-calculus mathematics, and 3 additional university prep courses. So let me contrast this Bachelor of Computer Science with the Bachelor of Applied Computer Science. So the Bachelor of Applied Computer Science is really about bridging the gap between technology and business. Think of this as a 70-30 degree. 70% computer science, 30% management, which is taught by our colleagues in the school faculty of management. These two programs share much of the first 2 years, but in both of these programs, those core development skills are essential. But this program adds to that management, breadth in computer science, and across the university. So this is really about how can we use technology to empower organizations to achieve their ends. So key skills: problem solving, design, communication, coordination, and organizational excellence. Here, in terms of admission requirements, again, the same grade 12 English, academic math, and 3 other acceptable university prep courses. So you're wondering, okay, what's at the core of this difference, this distinction between these two degrees? Well, the way in which they're the same is they both develop those core design and computing skills. The way that they're different is that the Bachelor of Computer Science aims towards real depth in the discipline, while the Bachelor of Applied Computer Science looks at harnessing computing for in order to connect to business and organizations and the things that they are trying to achieve. So what does a first year look like? Well, there's a common core between these two degrees. There's those introductory programming courses. There's a core sequence of courses, 1800 and 1801, which really look at the history of science and technology, and then really social and philosophical implications of computing. We want to make sure right from the beginning that the computer scientists that we graduate are thoughtful and think about how technology connects to the world around them. And then there's an introduction to computing systems and an introduction to web design and development. So that's the common core. And I want to point out at this point that we assume no experience in computing. Okay. About half the class each year coming into first year has had experience programming, and about half the class has not, has never written a line of code in their lives. And the interesting thing is, at the end of the first year, if you look at how people are doing, you can't tell these two groups apart. Um, Really, there's a different pathway of courses. Um, if you've never written a line of code in your life, you'll take 1105 first as the introductory and then go into 1110. And then if you're an experienced coder, maybe you want to start with 1110 and go from there. Now for the differences between these two programs. In the Bachelor of Computer Science, you're going to add the start of your 5 core mathematical courses. So you're going to take a calculus course and a linear algebra course, and then maybe you'll do a couple of other interesting computing courses, maybe social computing and experimental robotics. These are called science with labs, so they're very hands-on and interactive. If you're in the Bachelor of Applied Computer Science, perhaps you're going to take the same science with the lab courses, but instead of the mathematics, you're going to take an introduction to multidisciplinary management and then the follow-on course. So I'd like to tell you a little bit about the faculty and our values, what we think is important. I think, really at our core of our values is that we're a student-centric faculty. We care about the students that come into our program. We understand that computing is challenging, that in a 4-year degree, everybody is going to need help at some point. And we're very conscious of putting in systems to support you, the students. So up on the second floor of the Goldberg building, we run a learning center. This is staffed by students that have taken the courses that you're taking and are there as tutors. They can stand at the whiteboard. They won't solve your assignments for you, but they'll stand at the whiteboard and help you understand problems, understand issues that you may not have understood in the classes, and generally help you. We have a math learning center. We've got faculty advisors. Simply send an email to the address undergraduatecs.dal.ca at any time, and typically within 24 hours, you'll be sitting down with a faculty or staff advisor. One question that many people ask about is cooperative education. This is really a key part of our programs. So let me tell you what is co-op. Starting at the end, in the summer of your second year, so at the end of your second year, you can start co-op. So what co-op is a chance to get in real life industrial experience during the course of your degree and get paid for it. So you start in that summer, and at that point, you're going to alternate a work term followed by an academic term, followed by a work term, followed by an academic term, and so on throughout the rest of your degree. You're going to get this great experience of, and it's amazing how both the work term informs your classes. When you come back from a work term, suddenly you go, I get it. I understand why data structures are as important, or what's going on with this kind of issue in software engineering. So they really, the industry experience informs the academic just as the academic informs the industry. This is also a wonderful way to pay for your education. Co-op students in computer science do real work from day one. They work on real projects with colleagues in industry. Typically over the course of 3 co-op experiences, you'll be paid typically about $10,000 a term on average across the 3 terms. Not only that, but think about it. When you graduate, you're graduating with a year's working experience. And typically, roughly 50 to 60% of our students are going to start at companies they did co-op with. Why is that? Well, they know the company and they know it's a good fit for their interests. The company knows them knows that they're a good fit for the company, its culture, the kind of technology they're working on. And so there's a great match. And typically, these students are going to start with, considerably higher starting salaries than they would if they were just off the street. We manage the entire co-op process. We have a site co-op office, and it collects job postings, typically over 1,300 of them. It manages the interview process and the matching process. All you need to do as a student is prepare a resume, apply to jobs that are posted on the site, and go to interviews. All of the rest is going to be managed for you. I can't tell you how wonderful co-op is in building core skills and ensuring that at the end of your degree that you're going to connect in a really positive way to the workforce. Students often take two different routes through co-op. Some students go to their first co-op. They've always loved games, for instance. So they go to a gaming company and they spend 4 months of it, and they say at the end of it, wow, that was great, but I never want to work in games again. It's not what I thought it was. And so second co-op, maybe they do a co-op in cybersecurity. That's a great fit. They really like it. They do their third co-op with the same company, and they're off. Other students start at one company. In their first co-op, they really like the working environment. They do their second co-op at the same company. They do their third co-op at the same company. And on graduation, back they return. So there's different paths through it. But it's a wonderful opportunity to try different parts of the industry, try different types of roles, and figure out what's a great fit for you even before you graduate. And you will graduate, and you'll graduate into a fantastic job market. The demand for computer scientists has never been higher internationally. All of the predictions, if you look at the types of demand for different types of qualifications and educations, right at the top of that list today is computing. Here in Atlantic Canada, the digital industries are quite literally exploding. Their growth is tremendous. There are over 450 digital firms here in Atlantic Canada, hiring over 43,000 people directly employed, and that's not even the follow-on employment. $6.1 billion of revenue. We have local, national, and international firms here. Big firms like IBM, fantastic local firms like RedSpace, really representing the full gamut of computing opportunities. Digital is actually, Atlantic Canada's third largest export. Number one is oil and gas. Number two is lobsters. And just nipping at the tail of those lobsters is digital. And I suspect it'll catch up soon. So this is really a pathway that leads to great career opportunities, whether you want to stay here in Nova Scotia, here in Halifax, or you want to travel in Canada, or you want to go internationally. So a computer science degree is more than just a sequence of courses. Wrapped around those courses are a whole range of other opportunities for you. I'm just going to highlight a couple of them. We run something called Shift Key Labs. This is our innovation and entrepreneurship space. We run hackathons, a lab residency program, fireside chats with founders of startups, chances to build new technical skills in really hot areas, whether it's user interface design or cloud computing, and a chance to really interact with other students, with key industry players, and build a whole range of skills. We want to make sure that every student that graduates from the faculty is not ready only to go to corporate Canada, but is also ready to work in small businesses, and if that's where their passion is, to go into the startup ecosystem and build something for themselves. We've been very focused in recent years on thinking about who we are. And one thing that becomes really critical is recognizing that technology is fundamentally changing the world. And when you build software, that software represents your values, where you came from, your perspective. And so it's absolutely critical that computer scientists as a group represent society as a group, represent Canada. Um, and so that we've been very focused on our initiative called We Are All CS, which is focused on inclusiveness, in diversity, and making sure that we as a group represent society as a whole. Um, in recent years, we've tripled the number of women coming into first year computer science. We have a wonderful Women in Technology Society, uh, entrance scholarships, first year peer mentoring programs, chances to interact with industry leaders, um, a female leadership program in tech. Uh, all of this supported by a group of passionate, engaged industry partners who are here because this is incredibly important to them. They recognize that it is critical that their workforce also reflects society as a whole. We also have a really vibrant faculty in terms of societies. There's the Computer Science Society, Women in Tech Society I mentioned earlier, programming competitions, Shift Key Lab events. Um, the students run a student-run research conference every year, industry showcase events, and many, many other activities. So it's not just a sequence of courses, it's really a vibrant culture in which you can build your skills, your portfolios, you can engage broadly with the discipline and with its connections to the rest of the university. So lastly, maybe a bit of advice. Um, Computer science degree, it's a 4-year experience. Um, it's a critical underpinning to your future life and your career. It's an opportunity for you to explore. There are many paths through a computer science degree. Whether you're interested in going to, a startup, or you want to go to a Web 2.0 giant company like Google or Facebook, whether you're interested in combining this with science and bioinformatics, or you're interested in going corporate and working in corporate Canada. All of these are possible destinations that cut through a computer science degree. And we make sure that there are opportunities for you to explore and build a portfolio for yourself that's going to lead that way. So I'd say lastly, you own this experience. We are there to help and support you, to give you opportunities, and maybe to point the way. But this is really your experience. So I do hope that you'll join us here in the Faculty of Computer Science. Um, each year, this is the Dal Tiger welcoming you to the doors of computer science. Each year we have a new and exciting first year class, and we would be so happy to welcome you this fall.